This video is going to go over how to calculate percent compositions, and then in related videos we also have how to convert percent compositions into empirical or molecular formulas. So they're both kind of interchangeable ideas. We're going to start with this example for percent composition. We have nitrogen dioxide, and we're going to calculate the percent composition of this compound. So we're going to determine the percent composition of nitrogen dioxide in this example. So composition means makeup. And so you have to list all the elements that are in the compound. Whenever the question just says, what is the percent composition, or determine the percent composition of this compound, then that implies that you need to provide all of the elements that make it up and their percent by mass. So we have one nitrogen atom and two oxygen atoms. So nitrogen is here on the periodic table, 14.01 grams per mole, and oxygen is here, 16 grams per mole. So the percent nitrogen is the mass that nitrogen makes up in this compound divided by the total mass of the compound times 100 to get a percent. So since there's only one nitrogen atom, we have 14.01 atomic mass units divided by the total mass of the compound is 46.01 AMU. So 14.01 AMU from nitrogen divided by 46.01 AMU for the whole compound times 100 gives you 30.4499%. It looks like this is accurate to 4 significant figures, and so you're going to round this to 30.45% nitrogen. And then to finish the problem, the percent oxygen, there are two ways to figure that out. Since there are only two elements in this compound, you could just subtract 30.4499 from 100 to get the mass of oxygen. Or you could repeat the same process we just did for nitrogen, but for oxygen. Probably the wisest thing to do would be to pick one way and then verify the answer with the other way. So 2 times 16 is 32, divided by 46.01 gives me 69.55%. 4 significant figures. And again, if you can verify that if you add those two together, so this is the other way, or 100 minus 30.45 still gives you 69.55. You can do one way and then verify with the other method. If we do the same process for dinitrogen tetroxide in 2O4, what you might notice is that because there are 2 nitrogen atoms and 4 oxygen atoms, you really have the same overall percent composition for nitrogen and oxygen because you've just doubled the molecule. It's basically 2 of the same molecule over again. So whenever you have 2 compounds with the same empirical formula, they will have the same percent composition. So this would have the same answer. 69.55% oxygen and 30.45% nitrogen. You can always do it again to verify, but you would have 2 nitrogen atoms and 4 oxygen atoms in the calculation, and the overall molecular weight would be twice as large.